When the air comes out of the combustion chamber and comes into the turbine, it is very hot, and in fact the temperature in this area here could be maybe 200 degrees Celsius above the melting point of the turbine blades or the nozzle guide vanes. So these blades and vanes are operating in extreme temperatures. I suppose it's a bit like, you know, putting a block of ice into an oven and expecting it to remain a block of ice. And that is the job that the engine has in trying to cool the nozzle guide vanes and the turbine blades. So how does it do that? Well, what it does is it taps off high pressure compressor air and sends that to the high pressure turbine, and low pressure compressor air, and it sends that to the low pressure turbine. And the air here, even though this could be, you know, warm, I mean it'd be a couple of 100 degrees Celsius, in comparison to, you know, the air coming out of the combustion chamber, it's cool. So if we just take this high pressure compressor air, you know, it's fed along some route in the engine, and it comes up through the blade route. So this is the fir tree piece holding the blade in. The air comes up through there, and then there's an internal channel inside the blade that allows the air to flow and keep cool. So if we have, you know, very warm temperatures here, in comparison, you know, this is cool, and this cooling air helps retain the integrity of the air. The blades are lined with a number of little holes as well. So as the air comes out, there's these little holes in the blade, and the air can actually seep out through the blade on the leading edge and on the trailing edge, and even on the body. And there'll be some holes at the top here as well. Okay, so the air comes in, it goes out through these holes, but, you know, follows this route around the engine, and that helps to keeps the air, the turbine blades and the nozzle guide vanes cool. Okay, for the nozzle guide vanes, the air is tapped and it has to go in this route. So it'll come down through the nozzle guide vanes in these locations. Now you might be saying, well, why don't we just take the cooler air from the low pressure turbine and supply that to the high pressure turbine? Hope I've said that right. So taking cool air from the low pressure compressor and supplying it to the high pressure turbine. Well, the reason we don't do that is due to thermal shock. You know, the difference in temperature would just be too great, and that will cause a thermal shock, or may cause a thermal shock in the turbine blades, and yeah, we want to avoid that. So high pressure compressor air feeds the high pressure turbine, low pressure compressor air feeds the low pressure turbine.